Hi, so I wanted to go over one of your trigonometric application problems where you're trying to find the sinusoidal curve that will best fit the data given. So let's look through this and read the question. So the question states, suppose that the length of time between consecutive high tides is 12 hours and 26 minutes. According to the National Oceanic Atmospheric Administration, on a particular day in a city, high tide is at 12:26 a.m., which is 0.43 hours into the day, and low tide occurs at 7:05 a.m., which is 7.08 hours into the day. Water heights are measured as the amounts above or below the mean low or low water. The height of the water high tide is 5.92 feet, and the height of the water at low tide is 0.06 or 600ths of a foot. Complete parts A through C. So part A wants to know approximately when will the next high tide be? Well, if our first high tide occurred at 12:26 a.m., and we know that 12 hours and 26 more minutes will get us to the next high tide. Well, if I add 12 hours from 12 a.m., that's getting me to 12 p.m. So 12 p.m., and then I have 26 minutes plus 26 minutes, which would get me to 52 minutes. So this would be 12:52 p.m. is when approximately the next high tide would occur. So now we want to find the sinusoidal function of the form y equals a sine of the argument, which is omega x plus phi, and your argument plus b. We want to round our answers to the nearest thousandths. So let's first look at our amplitude. We can find our amplitude, which in our case is capital A. This is equal to the high tide. High tide was 5.92 feet minus our low tide. Our low tide was at 0.06 all over 2. So if we put that, if we take 5.92 minus 0.06, we get 5.86 divided by 2, which would give us that A is approximately 2.93. Okay, so we know what A is. We can find the vertical shift, which is our B value, by taking the maximum of the height of the tide, which is 5.92, plus our minimum, all divided by 2. So this gives us 5.98 divided by 2, which is equal to 2.99. Now we need to figure out what omega is. It tells us right here that the consecutive high tides are 12 hours and 26 minutes apart. So let's put that in terms of just hours. So I want to convert 26 minutes into hours. So I know that there are 60 minutes in 1 hour. So let's multiply that by 1 hour over 60 minutes. And so this is equal to 26 over 60, which reduces to 13 over 30. So that we have is now in terms of hours, just that 26 minutes. But we have the 12 hours plus the 13 over 30 hours. So let's get a common denominator, which would be 30. So multiplying our 12 hours by 30 over 30, this gives me 360 plus my 13 all over 30, which is 373 all over 30. So right there, that is what my period is. So I need to take my period, which is, we found 373 all over 30 is equal to 2 pi all over omega. So if we do a cross multiplying, we get 373 omega equals 2 pi times 30, or 60 pi. So omega here is 60 pi divided by 373. It's going to want us to round things in terms of the thousands. So let's put that and round it right now in terms of thousands. And so if you put that into the calculator, we get that this is approximately 0.505. So this is our period. Found B, we found A. Now we need to figure out what that horizontal shift is. Well, we know that our period was in terms of we said our period was this, we said their period was 373 over 30. And we want to break that down into quarters. And so let's look at 373 over 30 times 1/4. So we get 373 all over 120. And if you do that, you get that this is approximately 3.108. So if I was breaking this down and not thinking of any horizontal shift, and we're thinking of our sine function, we would go from 0 to 3.108. Then we would go from 3.108 plus another 3.108, which is 6.217. From 6.217, we would go to 9.325. And the last interval, 9.325, adding that 3.108. And I wrote it down. I didn't. So adding that, let me just do it really quick. So 5 to 13, carry my 1, that's a 3. It really doesn't matter. 3 plus 1 is 4. And that's 12. So 12.433. So normally our sine starts at our midway line, and then it increases. We hit our max. Our max normally, if there was no horizontal shift, would hit at 3.108. But if we look, our maximum tide occurred when we were at 0.043 hours. And normally, without any horizontal shift, it would be at 3.108 hours. So we're going to take the horizontal shift. It's starting at 0.43 minus 3.108, which we get that this is negative 2.678. So this is what our phi value is equal to. So far, let's write out what we have. We have y is equal to A. A we said is 2.93. All times sine. We have our omega, which is 0.505 x. We have parentheses here first. Parentheses x minus negative 2.678 in our parentheses. And then outside of the parentheses, we have plus 2.99. So let's just distribute this 0.505 inside the parentheses here. So we get y is equal to 2.93 sine of 0.505x plus, if you multiply 0.505 times 2.678, you will get 1.352, end your parentheses, plus 2.99. So we found our function that would give us the height of the tide after X hours into the day.